12.3, what we're going to do is we're going to solve radical equations. So far in Chapter 12, everything that we have done has been with radical signs. The radical sign, just remember, is the square root sign, okay? So we first learned how to graph them and how we know there can never be a negative number underneath the radical sign. Then yesterday we learned how to add and subtract radicals. We knew that if we wanted to add or subtract them, they had to be what we called like terms, which meant they had to have the same number under the radical in order to add the whole numbers. We multiplied and divided them, and we simplified radicals. So today what we're going to do is we're going to solve equations involving radicals. Basically, what that means is we're going to solve for x, okay? So in this first problem, we are going to solve these just like we would any other equation, okay? So that means I am going to try to get x by itself. So I know that x is equal to whatever it equals. So what do you think I should do first in this problem? Marcus? Add 10 to both sides, exactly. So now I have the square root of x is equal to 10. You cannot just drop the square root sign. And right now I don't know exactly what x equals. I know the square root of x is equal to 100, so I need to still get x by itself. Think about this. What did we just do to 10 to move it to the other side? We added it because it was being subtracted, so I did the opposite. So if I want to get x by itself, I need to do the opposite of a square root. Who can tell me what the opposite is? Not multiplication, square it, right? We use a power of 2. Now, what that does is that totally cancels out the square root sign. Whatever you do to one side, though, remember, I've got to do to the other. So if I square the left side, I've got to square the right. So now I'm left with x is equal to, what's 10 squared? 100. It is not 20, okay? It's not 10 times 2, it's 10 times 10. Now, here's the thing about these equations, is I've got to check my solution and make sure it's correct. Because sometimes I can get an answer, but when I plug it back in, it doesn't check out. Even though you've done everything correctly, it's what we call an extraneous solution. In something that looks like a solution, but it's not. So let's plug it in and check it out. So I'm going to do the square root of 100 minus 10 is equal to 0. What's the square root of 100? 10. 10 minus 10, does that equal 0? Yes. So I know that this solution is correct, x equals 100, and I can move on. But let's look at this next one. What should I do first? Subtract 5, and I have the square root of x is equal to negative 5. Now what am I going to do to get x by itself? What did I do in the last one? Square it. That cancels that out. Whatever I do to one side, I got to do to the other. What is negative 5 squared? Positive 25. So let's plug that back in and check. The square root of 25 plus 5 is equal to 0. What's the square root of 25? 5. Does 5 plus 5 equal 0? No. So that is not our answer. Our answer is no solution, because what I found was an extraneous solution. So it does not work. So your answer would just be no solution. Now, just because it doesn't work out does not mean you did something wrong. Okay? It just means the answer that we found, it looks like it works, but it doesn't. Okay? We did everything perfectly correct and found that x is equal to 25. But even when you check it, it doesn't work out. Okay, so your answer would just be no solution on those. So example 2. What do you think I should do first to solve this first equation? subtract 3. Now I have the square root of 2x minus 3 is equal to, what's 4 minus 3? 1. Now, here's the thing. In my first step, I cannot just automatically square it. You've got to move everything that's on the same side as the radical sign to the other side before I can square it. So now I can square and get my answer. So I'm going to square it here. That cancels that out. Whatever I do to one side, I got to do to the other. So now I have 2x minus 3 is equal to, what's 1 squared? 1. Now we just solve it like we would any other equation. What should I do first? Add 3. 2x is equal to 4. Then I divide by 2. And x is equal to 2. Now, let's plug it back in really quickly and check. 2 times 2 minus 3, the square root of 2 times 2 minus 3, plus 3 is equal to 4. What's 2 times 2? 4. 4 minus 3 is 1. What's the square root of 1? 1. 1 plus 3. Does 1 plus 3 equal 4? Yep. So I know that this is a solution. Alright, so let's do the next one. Well, what do I do on this next problem first? Add 2. Square root of 3x plus 1 is equal to 8. Now, Austin, what would I do?
Plug in 8 into x.
Did I find out that x was equal to 8? Did I get a final answer of x is equal to this?
No.
No, I'm still solving for x. So what should I do first?
Subtract 1. No.
1 is still underneath the radical sign. Square it. Because that's the opposite of square root. So whatever I do to one side, I got to do to the other. Now remember, Austin brought up a good point. He said, let's just subtract 1. But you cannot move anything underneath the radical until you get rid of the radical sign. Okay? So I can't just say, oh, let's just subtract 1, divide by 3, then square it. It doesn't work like that. You've got to do squared first. So then I have 3x plus 1 is equal to what? 64. Now I just subtract 1. 3x is equal to 63. Divide by 3. And x is equal to 21. Now let's plug it in really quick and check it. Square root of 3 times 21 plus 1 minus 2 is equal to 6. 3 times 21 is 63 plus 1 minus 2 equals 6. 63 plus 1 is 64. What's the square root of 64? Does 8 minus 2 equal 6? Yes. So I know that this is a valid solution. Just do not forget the square root sign. A lot of people forget it and they go, oh, 64 minus 2. That does not equal 6. So, no solution. That's not correct. Make sure you have your sign. Last example. Do I have anything that I can move first on this first problem here? Is there anything outside of the radical that I can move? No. Okay. In order to do anything, I can't just subtract x, okay? Because I can't just subtract x with something under the radical. I've got to get that radical to go away before I can even do anything. So what would I do to get the radical to go away? Square it. Cancel out. Whatever I do to one side, I've got to do to the other. So now I have 4x minus 3 is equal to x squared. Here we go. This is where your previous knowledge comes in. What we did in chapter 10. Do I have like terms here so that I can just solve for x? No. So what do you think I need to do? Subtract the 4, add the 3. Subtract 4x, add the 3. So I get 0 to one side and then factor. So, if I subtract 4x and then I add 3, because I'm doing the opposite, subtract 4x, add 3. Now, why couldn't I just subtract x squared? Because you never want a negative in front of the x squared. So now I have x squared minus 4x plus 3 is equal to what? 0. How would I solve for x? Is this my final answer? If I subtract 3, do I have like terms still that I could combine? Factor. So let's list the factors of 3, which are 1 times 3. Which ones add to give me 4? Obviously, 1 and 3. Oops. What are my signs going to be? Both negative. Now, is this my final answer? No, I got to keep going. That means x minus 1 equals 0, x minus 3 equals 0. Just solve for x, which means I add 1 to both sides, and I get x is equal to 1. And I add 3 to both sides, and x is equal to 3. Now, because I have two answers, one of them could be a solution, and the other one cannot. They can both be solutions, or they can both not be solutions. So I've got to plug them in and check both of them. So let's just do that real quick. Square root of 4 times 1 minus 3 is equal to 1. Because whatever I plugged in for x, I plug it there. It's right here in this equation, the original. 4 times 1 is 4. Minus 3 is equal to 1. What's 4 minus 3? Does the square root of 1 equal 1? Yes, so I know that this is a valid answer. Now let's do that same thing but with 3. Yes. All right, what's 4 times 3? What's 12 minus 3? Does the square root of 9 equal 3? Yes. So I know this is also a solution. So both of them are solutions. You do have to check both of them because sometimes one will be and one will not. Just because the first one checks out does not mean the second one will. Or just because the first one is no solution doesn't mean the second one will be no solution. All right, and last but not least, this problem here. First of all, I want somebody to read me this problem. Marcus, read it for me.
2 minus 2 times x times the square root of x plus 5.
Perfect. Did everybody hear what he said? He said 2 minus 2 times the square root of x plus 5 equals 0. So what is happening between this negative 2 and the radical sign? Multiplication, okay? So I cannot just say 2 minus 2 because this right here is one term. And is 2 its like term? No, so I can't just subtract them. Just like yesterday when we said 2 minus 4 times the square root of 3. Could I just subtract those? No, because these are not like terms. Just because this one has more than one thing underneath the radical does not mean it changes anything. They're still not like terms. So I've got to move what first? This 2. And how would I move it? Subtract. Because it's a positive, I've got to subtract. So now I have negative 2 times the square root of x plus 5 equals negative 2. How am I going to move this negative 2 over here? Would I add? Is it being subtracted? You divide. Remember, this is exactly why I had you read it. 2 times. So the action that's going on is multiplication. So the opposite is division. So now I have the square root of x plus 5 equals what? 1. What would I do now to solve? Square it. I got to get rid of the square root sign. X plus 5 is equal to 1. Then I subtract 5 on both sides, and I get x is equal to negative 4. Can I just go ahead and say right off the bat that's my final answer? Nope, let's check it. 2 minus 2 times the square root of negative 4 plus 5 equals 0. What's negative 4 plus 5? 1. What's the square root of 1? Anybody? What's the square root of 1? 1. So now I have 2 minus 2 times 1 equals 0. Well, what's 2 times 1? Or negative 2 times 1, I'm sorry. Negative 2. Does 2 minus 2 equal 0? Yes. So I know that that is a valid answer. That's how we would do it. Okay? That's how you do lesson 12.3, solving radical equations.